Hi, I'm Kylie Cooper, and I'm a technical sales engineering intern for the St. Paul office for Trane Technologies. And today I'm going to be comparing the refrigeration cycles for two separate modes, the 100% cooling mode and the 100% heating mode. So both of these modes are actually going to start in the compressor, where a low pressure gas will be turned into a high pressure gas, and then after this high pressure gas will be sent to the oil separator, which is going to take out the oil that was needed to lubricate the compressor. And then this next step is where the two modes are going to differentiate from each other. The reversing valve is going to send the cooling mode one way and the heating mode the other way. So the cooling mode is actually going to be sent towards the condenser first, so that high pressure gas can be turned into a subcooled liquid. But the condenser will actually turn that gas into a saturated liquid/gas mixture, and then it will be fully turned into a liquid subcooled mixture with the BC controller. That BC controller is going to take that subcooled refrigerant and basically use half of the refrigerant to cool the other half. And so that half that was used to cool the other half is going to turn into a gas and stay in the BC controller. And then that fully subcooled liquid will be sent towards the indoor units. And they'll pass through the expansion valves first, which will determine how much of the refrigerant needs to be passed through to either cool the room more or cool the room less. And once that refrigerant is in the indoor units, that refrigerant will absorb heat from the room and turn back into a gas. And that heated gas will then travel from the indoor units back towards the BC controller, where it will meet up with the other half of the refrigerant that was turned into a gas already. And that gas will all go back towards the accumulator, and then the cycle will start back over again, starting with the compressor. So we'll go back to the heating mode. So the heating mode was actually sent to the BC controller first, where the rest of that gas will be superheated at the BC controller and then sent towards the indoor units right away. Once in the indoor units, the heated gas will absorb the cold air from the space, and it'll turn back into a liquid. So then that liquid will be sent from the indoor units back out of the expansion valves. Those expansion valves are going to still be controlling how much refrigerant is going to be let through, so that no area gets too high pressure or too much refrigerant that it can handle. And so after the expansion valves, the liquid will be sent back through the tube-in-tube heat exchangers, which will basically just make sure that all of it is going to be a cooled liquid/gas mixture, which after that tube-in-tube heat exchanger, it will go back towards the condenser, where the condenser will turn that any leftover liquid that was created in the indoor units will be turned fully into a gas again. So that condenser will convert the liquid gas mixture into a full gas mixture. And the solenoid block, which is right before the condenser, will still control how many coils are going to be used, which both will be used in this case again. So then the condenser will turn that back into a superheated gas, and it will be sent back to the accumulator to go through the whole cycle again. So these different modes are very similar to each other. They're just basically one's going one way through the system and one's going the opposite way through the system, which, if you think about it, makes perfect sense. So yeah, it's just basically a big cycle, and heating goes through one side, cooling goes through the other. So thank you.